Last week we talked a little bit about water heating, and I touched base on why I leave the plans open-ended with regards to water heating, and it's because every situation has such specific different needs and goals and there's so many varied ways to interface the water system with the heater and to build the complete water system, that it's really beyond the scope of stove design plans to incorporate all of that information. But I'm happy to talk through what those things, what options might be the best for you when you are planning out your water system. So with that said, I said that last week, and then I got a great question from a wonderful customer, and he asked me, he says, could you just elaborate on some of that stuff? Can we talk a little bit about it? He says, the idea for my stove is primarily for cooking on the cooktop and any of the residual heat going into the mass of the water for later use. So he gives, a little bit of insight into what his goals are and what his use application is. And then he goes on to ask me some more specific questions. He says, what kind of tanks do you think are ideal? Can you have the exit of the riserless core blasting onto the tank versus having flue gases contacting it further downstream? What are the safety aspects of bare coils versus a tank filled with water with a coil inside? What are the benefits of a bare coil versus a tank filled with water? Oh, those are the same question. Safety aspects, I see. What are the safety aspects, and then what are the benefits of either a bare coil, like an air-to-water heat exchange, or a water-to-water heat exchange? So those are some great questions, and I'd love to talk about it. If you guys have any input, I'd love it. Let's talk a little bit about water heating. There's so many ways you can do it, right? You can use air to water, where you have a coil kind of somewhere in a hot spot, and where you put that is really dependent on a lot of factors. Incoming water temperature, flow rate, what your goals are for hot water production. All of those things are going to change where you put this air-to-water heat exchanger. An air-to-water heat exchanger does have some risks, right? You can get it so hot that it could flash the water to steam instantly when the water comes in if it ever runs dry. It also is possible to be in such a hot spot. We have output at the output of the riser at like 900 degrees. So if your water isn't moving fast enough, you can flash that to steam in no time and create a really dangerous situation. So air-to-water heat exchangers are really useful when you want the fastest heat exchange, but they do come with risks, and they do kind of, there's sort of a narrow window of operation there, and a broad range of failure, I guess is how I'll say it. They require things to be balanced just right, I guess is the best way I would put that, because you have to keep that coil under boiling by running fluid through it fast enough that's cool enough to keep it at that temperature, and where in the system it is, and all those things are variables. And so then when you run into talking about someone's individual system, you ask them what size are their main pipes, where is the water coming from? Is it in a tower? Is it warm? Is it cold coming out of the ground? Is it cold? What kind of pump do they have? Can they run fluid through there quickly? Can they ensure that the pump won't fail? So there's a lot of questions there, and so there's too much to really say when do we use this or when do we use that exactly. But what you can gather from this is that an air-to-water heat exchanger or coil in the hot parts of the stove is ideal for things when you want to exchange heat quickly and you don't mind having some mechanical stuff involved. You can make it faster and riskier by moving it closer to the riser and closer to the hotspot, and you can make it safer and slower as you move it farther away. So my general advice is I'll try and put that coil somewhere where I expect to be just a little hotter than boiling most times. So I like to put it usually like in the top of the oven section. That's somewhere that's going to be, on average, it'll rise up to 400, 450 degrees, but it'll on average be around 300 degrees. And at that temperature, you can run water fluid through there at a reasonable flow rate and really not have a very high risk of ever boiling it off. As you play with your system and your flows, you're going to probably want to move that coil higher and lower in that chamber. Stratification plays a big role in the temperature of where what's going on inside that chamber. So there's a lot of ways you can tune the stove just by moving that around. Now that's just one way of doing that. Now in my ideal world, that coil is always going to be in a downdraft section of the stove, okay? Because anytime the gases in the stove come in contact with that coil, they're going to cool. And as soon as they cool, they're going to contract and become more dense than the gases around them, which are hot, and so they will start to sink. So if you put the coil in a downdraft section, you will be working with the natural physics of the stove. The gases will want to flow down naturally through that coil as they are cooling, and so the stove will flow with less resistance and transfer heat to that water much better. So that's the idea with the coil. Put it somewhere where the air can, or the gases can flow down through it or around it, and ideally somewhere where the heat of the stove matches your goals. Now I've had people who went into a hot tub and they put that coil right over the riser and they had a pump on it, and it works great for them. You can heat a lot of water quickly, but you need to manage it. So there is kind of a coil. Now what about a water to water heating system? So in this case, we'd have a tank full of water in the stove, and we'd probably run a coil through that tank. And that's how I do my boiler. And the reason for that is it's just really simple and really safe, and it offers a really wide range of operation that's safe. It can be really hot fire, it can be a cold fire, it's really hard to create a dangerous situation in there. The big tank is open to the atmosphere. It can boil, and it'll just boil off. You've got hopefully a float valve and an autofill on it, or a float stick, and you can just make sure it isn't going to run dry. And then you run your coil through it, and again, your coil ideally would be it wouldn't be a pressurized system anywhere in the stove. I would put the valve at the back of the flow, and then I would push water through the coil. But regardless, it's going to be really hard to flash boil anything in that coil because you have to boil the whole tank first. So with that said, now you can put that, now you're really free where that tank can go in the system. You can put it right over, as the email asks. He says, can the eggs of the riserless core blast right onto the tank? Absolutely, because the water in the tank is going to protect that steel from ever overheating. So you can have the tank right over the riser or riserless output, and you can get full heat to that tank and heat it up relatively quickly. Or for really simple passive systems, you can put that tank somewhere way downstream. Like in my case, of the tiny stove, I think a great place for a tank is the bottom oven chamber because it'll never really get much above 250, so you almost don't even have to ever worry about it boiling. And in a situation like that, you won't heat a lot of water quickly, but you could always have 10 gallons warm, and probably never worry too much about it being a danger. So again, this really all depends on your goals. Do you just need one shower a day? I'd go with like a really simple water tank way downstream in my system, somewhere where it's just going to hang out at like 150 degrees, depending on how you're going to use it. If you're going to run a coil through that and then heat the water from there, if you're going to use it directly, you've got a few different options there. So there's a myriad of ways you can go, and I can't go all the way into that, but hopefully you guys are starting to see the idea that you can go for high volume water production, but it's going to be a little riskier and it's going to take more control and more management. Or you can go for sort of lower volume or, well, lower temperature water production and put it downstream and just have it be a really passive system. And it really, again, really depends on what you're going for. If you're trying to get a family of 5 to shower all day and do laundry and wash dishes, you know, you might do it with one of my boilers, but you're gonna need a big giant storage tank that's external. You're gonna you know, run that boiler for a few days, heating up 1,200 gallons of water, and then you should be able to keep up by running that boiler for a few hours a day. But those are the ways to think about it. The stove really just provides the input into the water. It doesn't have any significant storage built in. You can definitely heat large amounts of water and use large amounts of hot water, but you need much larger storage facility than you have in that small boiler. And so, you know, for people who have larger needs for heating, whether it's you know, they actually want to use the hot water, or if they want to use water in radiators or things like that, I think the smaller rocket boilers are a great choice, but you need to make sure that you plan for a large buffer tank that's going to increase your thermal storage, because you can't burn that stove 24 hours a day. But if you burn it for 6 hours a day, you could have hot water for 24 hours a day with a big buffer tank. So there you go. That's a big part of that. And then he asks also, what kind of tanks do you think are ideal? You know, that's a great question. I get a lot of people saying, I'm going to buy a copper tank, I'm going to buy a stainless tank. And of course, my plans just show it with a plain steel drum. And so what are the benefits or choices there? Well, the plain steel drum is free usually, and so I love that. You know, you just can salvage it anywhere. It will rust out, so you know it's not a permanent solution, but it's probably going to be years before it develops a pinhole leak. I mean, maybe a decade. And the way I build the boiler, it's easy enough to just lift the top and change out the barrel. So free's pretty good, and I think that's a totally reasonable way to go. Stainless barrels are pretty expensive, but not terribly expensive. I think they're a few $100s. It's a good choice. It will work great and last, I think, essentially forever. The only downside to the stainless is it's not a great conductor, but I don't know that that's really that relevant in this application, since it's so thin and we've got great contact with water from the inside and gases all around it. I don't know that that's highly relevant. But last but not least would be a copper container, which I think is probably the ultimate. You can find them sometimes in old water heaters. Often they'll be cast iron, but there are some old ones that are copper. That's really the ideal choice, but it's so cost prohibitive that it's not really a very realistic choice for many people. And Permaculture Playground says, what about using a beer keg? I think that's a totally reasonable choice, Permaculture Playground. It's stainless again. It's probably a little thick-walled, so it might not be ideal, but you know, they're available for salvage and they're a good size. I think it'd probably be just great. When we talk about these things, and I'm talking about conduction and things like that, I think we're talking about really small increments in terms of, you know, using copper over steel or stainless, you know, inside of there in the tank because of the things we just talked about. I'd be pretty surprised if there was a huge advantage to copper, for instance. I think there is an advantage, but I don't know that it's like a, you know, I think what I'm trying to say is I think the keg would be fine.